Oops. Oops. All right, we will just wait a little bit. More people to join us here. We are so close to the end, you guys. All right, I'm just going to PowerPoint out here. Okay. Right. Okay, a couple of things to mention to you guys here before we get started. So don't forget, those of you who have not written the musculoskeletal system exam, that is open until tomorrow at noon, so make sure that that gets done. A couple other things. What else is there? Friday's class. I have an appointment on Friday, so we're going to do a Thursday class this week instead of a Friday class. Okay, so that should be the only major change in our schedule. So we will have a class Thursday instead of Friday, and I will put that in my notes after this class. All right, so sports nutrition is our very last unit. I will have a worksheet for you guys that I'll share with you before 5 o'clock today. I probably won't have time to get to it before 5 o'clock. That'll be due on Wednesday, just on some of the stuff that we will be working on today and that we did last class. All right. So make sure that you get that done. And I also remember the workbook has blanks in it that you can fill in as we go through the PowerPoints. So anything that's underlined in the PowerPoint is something that you can add to your workbook. And it shouldn't take you too long to add that as we go through it. All right, so without further ado, we are going to start talking about nutrition. So last class, when we did this, we were talking about basically what a calorie is. So we learned a little bit about that. And we learned a little bit about what do we need every day for our calories. And when we account for what we need every day for our calories, we're looking at things like the age of the person. As we get older, we don't need as many calories. We're looking at the gender. Females tend to need fewer calories than males. We're looking at level of activity. We're looking at how big someone is, so their mass and their height. So all of these things go into what we need for our daily caloric requirement. And then we know that different activities burn different amounts of calories. So if we're doing a lot of activities that burn a lot of calories, obviously we're going to have to take in more calories. Okay, so today we're going to talk specifically about a few nutrients. I think we're only going to get through carbohydrates and fats and maybe a little bit of proteins today. All right. So without further ado, let's get started on our PowerPoint. Oh, the other thing I wanted to mention, for whatever reason, I didn't put the PowerPoint that I added supplements to online. So this one here, I changed it, so it's fixed, but I will be constantly updating it. Did I just do this properly? I don't think I did. I will be updating the PowerPoint because it's a long PowerPoint and I haven't quite finished updating everything, but it is updated to where we're going to cover today. So when you print out the PowerPoint, I'd only print out, if that's what you want to do to help you study, I would only print up to the point where we got in class. Okay? All right, so we're just going to go to where we got to last class, which was carbohydrates. All right. There we go. All right, so carbohydrates. We're just going to watch a little video on carbohydrates to start off with. It gets in a little bit more detail than what we need to know, but it does help us understand the difference between our starches and our simple sugars and how our body actually benefits from having more starchy food. So we'll just take a minute to watch that here, or more than a minute. So I'll just share that with you. Oh, whoops, I don't think I shared it properly. Share.
Which of these has the least carbohydrates? This roll of bread, this bowl of rice, or this can of soda? It's a trick question. Although they may differ in fats, vitamins, and other nutritional content, when it comes to carbs, they're pretty much the same. So what exactly does that diet? First of all, carbohydrate is the nutritional category for sugars and molecules that your body breaks down to make sugars. Carbohydrates can be simple or complex, depending on their structure. This is a simple sugar, or monosaccharide. Glucose, fructose, and galactose are all simple sugars. Link two of them together, and you've got a disaccharide, lactose, maltose, or sucrose. Complex carbohydrates, on the other hand, have 3 or more simple sugars strung together. Complex carbohydrates with 3 to 10 linked sugars are oligosaccharides. Those with more than 10 are polysaccharides. During digestion, your body breaks down those complex carbohydrates into their monosaccharide building blocks, which your cells can use for energy. So when you eat any carbohydrate-rich food, the sugar level in your blood, normally about a teaspoon, goes up, but your digestive tract doesn't respond to all carbohydrates the same. Consider starch and fiber, both polysaccharides, both derived from plants, both composed of hundreds to thousands of monosaccharides joined together, but they're joined together differently, and that changes the effect they have on your body. In starches, which plants mostly store for energy in roots and seeds, glucose molecules are joined together by alpha linkages, most of which can be easily cleaved by enzymes in your digestive tract. But in fiber, the bonds between monosaccharide molecules are beta bonds, which your body can't break down. Fiber can also trap some starches, preventing them from being cleaved, resulting in something called resistant starch. So foods high in starch, like crackers and white bread, are digested easily, quickly releasing a whole bunch of glucose into your blood, exactly what would happen if you drank something high in glucose, like soda. These foods have a high glycemic index, the amount that a particular food raises the sugar level in your blood. Soda and white bread have a similar glycemic index because they have a similar effect on your blood sugar. But when you eat foods high in fiber, like vegetables, fruits, and whole grains, those indigestible beta bonds slow the release of glucose into the blood. Those foods have a lower glycemic index, and foods like eggs, cheese, and meats have the lowest glycemic index. When sugar moves from the digestive tract to the bloodstream, your body kicks into action to transfer it into your tissues, where it can be processed and used for energy. Insulin, a hormone synthesized in the pancreas, is one of the body's main tools for sugar management. When you eat and your blood sugar rises, insulin is secreted into the blood. It prompts your muscle and fat cells to let glucose in and jumpstarts the conversion of sugar to energy. The degree to which a unit of insulin lowers the blood sugar helps us understand something called insulin sensitivity. The more a given unit of insulin lowers blood sugar, the more sensitive you are to insulin. If insulin sensitivity goes down, that's known as insulin resistance. The pancreas still sends out insulin, but cells, especially muscle cells, are less and less responsive to it. So blood sugar fails to decrease, and blood insulin continues to rise. Chronically consuming a lot of carbohydrates may lead to insulin resistance, and many scientists believe that insulin resistance leads to a serious condition called metabolic syndrome. That involves a constellation of symptoms, including high blood sugar, increased waist circumference, and high blood pressure. It increases the risk of developing conditions like cardiovascular disease and type 2 diabetes, and its prevalence is rapidly increasing all over the world. As much as 32% of the population in the US has metabolic syndrome. So let's get back to your diet. Whether your food tastes sweet or not, sugar is sugar, and too many carbs can be a problem. So maybe you'll want to take a pass on that pasta, sushi roll, pita burrito, donut burger sandwich.
All right. So we don't want to start thinking that carbs are bad for us. Carbs are our way to get energy. So carbs are good for us. But what they're talking about here with insulin resistance, so insulin's what regulates our blood sugar level. If we have too many simple carbs, so therefore raising our glycemic index really high, that actually can cause our cells to become resistant to insulin, where insulin doesn't work anymore, which means our blood sugar level stays really high, and that can lead to a condition called type 2 diabetes. Okay, so we want to not have really high levels of simple carbohydrates. Okay, so let's go back to our PowerPoint here and talk a little bit more about carbohydrates. Okay, so again, we see these little blanks here. So these blanks that you're seeing on the PowerPoint, those are what you're going to fill in your sports med booklet. Okay, so preferred source of energy for the muscles and the brain are our carbs. So we want to keep that in our mind, right? Our body uses carbohydrates as an energy source. So easiest way to increase carbs, add more grains, more starchy vegetables. Starchy vegetables tend to be vegetables that grow in the ground, like carrots, beets, potatoes, right? Those have the higher starch content. Fruits have carbs, obviously beans and lentils. 1 gram of carbs is about 4 calories, okay? Right. So just a supplement here about low carb diets. So there was a big fad for a period of time that you should be having a diet that's low in carbs. And I never fully understood that because carbohydrates are in our fruit, right? So there's lots of sugar, fructose, in our, let's say, strawberries, right? So you don't want to avoid eating fruits and vegetables because they have carbohydrates in them. Because besides the carbohydrates, they're jam-packed with all sorts of different nutrients, vitamins, minerals, etc., and fiber, which are all good for us, right? So a low-carb diet is really not sustainable, right? Because that's carbohydrates is how our body gets their energy. Remember, that's the first thing our body does to get energy is it takes it from our carbs or our carbohydrate storage. Then it goes to fat, and then as a last resort, our body will try to break down protein, okay? So usually low carb diets aren't sustainable. So you might be on one, you might end up losing some weight, but you can't just keep living that way. And then if you're a training athlete, you're actually going to need to increase your carbohydrates in your diet because you're burning so many more calories. So you need to replenish those lost calories. Okay. So the key to a healthy diet is choose whole grain carbohydrates. So instead of choosing carbohydrates that are just simple sugars and that's all they are, like a can of Coke, right? You want to choose carbohydrates that are whole grain. So go for the whole wheat bread instead of the white bread. Go for the brown rice instead of the white rice. Okay, little changes like that. Limit foods with added sugar. I said this to you guys before. If you go down the cereal aisle at the grocery store, there are a tiny, tiny handful of cereals that you can buy that don't have sugar added. So shredded wheat was one of the only ones that I found. And then if you buy like oatmeal or steel oats, steel cut oats, things like that, that haven't been processed really at all. So you want to limit, you want to look at the ingredients. If they added sugar to it, and then eat plenty of fruits and vegetables, right? Because these, while they have the carbohydrates that we need to maintain our energy levels, they also have lots of fiber, and they also have lots of other nutrients that we need. Okay, so healthy sources of carbohydrates. So fruits and vegetables, okay, like I just said, you want to go with lots of colors. The more colors we have, the different variety of nutrients and vitamins that you're getting. You want to limit juice consumption, okay, because juice is more filled with the sugar part and doesn't give you the benefit of the fiber part. Juice doesn't fill you up as much, so it doesn't give you that satiation, right? So the latest food guide that came out this past year says limit juice, right? It's no longer recommending juice as a way to get our nutrients. Go with whole grains instead of the ones that are made of white flours, okay? Milk products and alternatives. You want to be looking at your percent of milk fat or percent of butter fat. You want to go for the lower fat versions. Meat and alternatives. So some ideas of healthy carbs that we can have is try legumes. So that dried peas or beans or lentils. And I talked about beans before, like red kidney beans or white kidney beans. And actually, I was at a session with a nutritionist. Whether you start with them dried and rehydrate them yourself, or whether you buy them canned, really makes no difference, other than some of the canned ones have some salt in them as a preservative. But if you rinse them off a lot, you can get that salt off. So she really said there's not much difference in nutritional value, and canned is just easier. Okay. So glycogen, it's a big word here. Glycogen is how our body stores carbohydrates. So again, these are the blanks you're going to fill in your booklet. Glycogen exists in our muscles and in our liver, okay, which is right by our stomach. So glycogen exists there. And when we exercise, so remember what I said, carbohydrates are what get used up first. So when we exercise, that stored glycogen that's hanging out in our muscle and our livers, that gets used up first. Once that's used up, then we go to alternative energy sources, our fats, and then if we completely run out our protein, which is not what we want. We don't want our body to break down our muscle, okay? Here's something interesting about glycogen. So remember, glycogen is animal starch, okay? Just like plants store their carbs in starch, we store our carbs in glycogen. The more fit you are, the better your muscles are at storing glycogen. So we have more stores, which is really good, because if we have a little bit too much that we're not using, instead of it going to fat, it's being stored here in our glycogen, in our muscle and our liver, okay? So the more we exercise, the more glycogen we can store, okay? Because our body's building that up to be ready for that level of activity that we have. Okay, so I added a supplement here. So our muscles can store about 400 to 500 grams of glycogen, which correlates to 1,500 to 2,000 calories of stored energy. That's a lot of stored energy. Now remember, our body needs energy when it's resting, right? So our heart can beat, so our smooth muscle in all the parts of our body that have smooth muscle, our respiratory tract, digestive tract, all of those can function, right? But we can store about that much. Exercise depletes our glycogen stores, okay? So we need to eat carbs to replenish those stores. Okay, there's 3 types of carbohydrates. So simple carbs, so that's what they talked about in the video. Those are the things that lead to a higher glycemic index, okay? So they're digested and absorbed quickly for immediate use as energy, okay? So we get these from our fruits and vegetables. There's some milk products that have it. Added sugars. Now, of course, we want to reduce our intake of added sugars. If we want to get energy, we want to make sure that we're getting energy that mixes that simple with other nutrients that are important to us, okay? So when are we going to use simple carbs as an athlete? As an athlete, you want to use them before, during, or right after a quick burst of energy, okay? So you want to consume them just before, during, or immediately after activity, because they break down super quickly into energy. So you can replenish energy very, very quickly, okay? So those are the types of carbs that we would like to have. So an orange, for example, would be a good example, because we get that fructose from the orange. We get other nutrients from the orange as well. So it increases our energy level, okay? Very, very quickly, for when we're doing in the middle of an activity, or right before or right after the activity, okay? Starches. Now our starch are complex. Remember, starch is a lot of units of those simple sugars all strung together. That's our starch, okay? It takes longer for starches to be digested. So things that we get starch from, starchy vegetables, like I talked about, grow under the ground. Other types of starchy vegetables would be like peas and corn. They have lots of starch in them. Grain products, anything that's made with wheat or rye, or those types of products, beans and lentils. So when should an athlete consume starch? So 2 to 4 hours before going for their exercise, their competition, their game, what they're doing, or directly after an activity. Okay, so if we think about that a little bit more, the reason why you're going to want to do 2 to 3 hours before is it's going to take time because your body slowly digests these. As we digest, we take that substance and we slowly turn that, our body turns that into something we can absorb into our cells and then uses energy. Because starch takes a long time to go through that process, right? Longer than simple sugars. Simple sugars, it happens really fast. Starch, it takes a long time, so we want to give ourselves time in order to digest and pull the energy out of that so we can use that for our competition. This should say competition. Whoops, not completion. I'll have to fix that afterwards. Okay, that should say competition. So immediately after competition, because the body needs to replenish our energy stores, because you've taken that amount of glycogen and there's not very much left, if there's any left, right? So we want to have those carbs to rebuild those glycogen stores. Okay. Spotlight here. All right. The last type of carb is our fiber. So they talked about that in the video as well. They talked about fibers, which are basically the same thing as starch in that they're long sections of these simple sugars all tied together, but our body doesn't break those bonds, okay? So we can't use fiber as an energy source. So it can't be digested and absorbed into the bloodstream. So things that would have fiber in them are whole grains, okay? Beans and lentils. We see lots of mixtures of beans and lentils in the image here. Meat and alternatives, which include beans and lentils, okay? When might an athlete consume high fiber foods? Okay, in meals or snacks 2 hours or more away from intense activity. So 2 hours before, 2 hours after. We don't want to have them in that window, right? That 4-hour window before and after, we don't want to have these fibers, okay? We want to have them on the outside of that window. So fibers, 2 hours or more before competition. Why? Fibers work to slow digestion, okay? So I'm eating other foods, right? Fibers are going to slow the digestion of all of those foods, which means my body's not using them as quickly to give me energy, so I'm not as ready for the competition as I want or need to be. Fiber can also cause bloating. Bloating means we get more liquid between our cells, and sometimes bloating happens in our stomach and give us stomach cramps. And we're not really ready to go into a competition when we're feeling that way. Now we want to wait till about 2 or more hours after competition as well, because again, fibers slow digestion. So we need to replenish those glycogen stores really quickly after the competition, right? So our body can repair itself, right? But that fiber slows that access to energy, so our glycogen stores don't get replenished as quickly. Okay, so more about fiber. Fiber is the indigestible part of carbohydrates, so the part we can't digest. So when I think about fiber, a good example of that is when you're eating celery. You know how celery has those little stringy bits? Think of those as fiber. Our body doesn't actually break those down. Often what happens is there's bacteria in our digestive system that break fiber down. And as they do that, they make gas. And as they make gas, then we can start feeling a little bit gassy ourselves, okay? It does help us with getting some of our vitamins, having those bacteria there. Helps reduce the risk of some heart diseases, okay? Because fiber can reduce the bad cholesterol. Cholesterol, remember, bad cholesterol starts building up in our blood vessels. And as it builds up in our blood vessels, they start to thin and our blood pressure rises and our blood's not getting to the organs as efficiently as it needs to. It can also help to reduce the risk of some cancers. Fibers also cause us to have bowel movements. So they cause us to poop or have that urge to poop, which is important because everything that's left in our large intestine has toxins in it. And the more we can get rid of that, the less it's going to have an impact on the cells in our large intestine. So we can actually, by eating more fiber, reduce our risk of some cancers, including colon cancer. Okay, helps regulate body weight. Well, because we're having fiber, fiber makes us feel full. So we're going to eat less because we feel more full. Okay, decreases the risk of type 2 diabetes, keeps that glycemic index low, prevents constipation because it's stimulating us to have bowel movements. Okay, so there are two types of fiber. There's soluble fiber. So soluble fiber tends to be stuff that will gain a lot of water. So if you mix your oats with water, your oats will start to gain a lot of water, or your dried peas, your lentils. So usually it's stuff that will gain water. Slows the absorption of food in the body, right? So that helps us to be less hungry, helps reduce cholesterol. Insoluble fiber, okay, so this is fiber that usually doesn't get filled up with water. So insoluble fiber provides roughage, so that roughage stimulates us to have a bowel movement and therefore reduces constipation. So if we want to start increasing our fiber, we want to make sure we're increasing the liquid in our diet as well. Okay. All right, so fiber recommendations. So the average Canadian consumes about 10 to 20 grams of fiber. So that's usually not enough. We usually want to have an average of about 25 grams of fiber every day. And you can look on the labels. The labels indicate how much fiber there is per serving of a particular substance. So if we look at people in your age group here, which happens to be the same age group as me, 25 grams for females and about 38 grams for males. Okay, that's how much fiber you want to be consuming on a daily basis. Okay. All right. So high fiber intake is important for athletes. The reason why it's important is high fiber also usually has a lot of starch, and starch gives us energy and fills our glycogen stores. Okay. When should athletes consume foods high in fiber and why? Okay, so 2 hours or more before an activity, again, to get energy from the starches. When shouldn't athletes consume foods high in fiber? Right before or right after competition. Remember, we want to have that 4-hour window, 2 hours before to 2 hours after, because that slows digestion and therefore limits our ability to access that energy that we're going to need before competition, right? Or the energy we're going to need for recovery after the competition. All right, carbohydrates requirements for training. Carbohydrates, high quality carbs are needed to fuel our muscles and to prevent fatigue. So we need carbs. So if you're just a person who exercises on a recreational basis, like we all should be, focus on fueling well. You just want to have the right amount of carbs each day, sort of follow the Canada Food Guide. But if you're a competitive athlete, you're going to need to have more carbs every day because you have more energy demands. You need to keep replenishing those glycogen stores. Okay. All right, fats. Any questions about carbs? Okay, so we're going to watch a little video about fats just so we get a sense of what we're talking about with fats, and then we will do our notes on fats. Oops. Okay, I'll just share this with you. Come on.
Olive oil is 100% fat. There's nothing else in it. Pancake mix, on the other hand, is only about 11% fat. And yet, olive oil is good for you, and pancake mix is not. Why is that? As it turns out, the amount of fat we eat doesn't impact our weight or our cholesterol or our risk of heart disease nearly as much as what kind of fat we eat. But let's back up. What is fat? If we were to zoom in on a salmon, which is a fatty fish, past the organs, past the tissues, into the cells, we would see that the stuff we call fat is actually made up of molecules called triglycerides, and they are not all alike. Here's one example. Those 3 carbons on the left, that's glycerol. Now you can think of that as the backbone that holds the rest of the molecule together. The 3 long chains on the right are called fatty acids, and it's subtle differences in the structures of these chains that determine whether a fat is, let's say, solid or liquid, whether or not it goes rancid quickly, and, most importantly, how good or how bad it is for you. Let's take a look at some of these differences. One is length. Fatty acids can be short or long. Another, more important difference is the type of bond between the carbon atoms. Some fatty acids have only single bonds. Others have both single and double bonds. Fatty acids with only single bonds are called saturated, and those with one or more double bonds are called unsaturated. Now, most unsaturated fats are good for you, while saturated fats are bad for you in excess. For saturated fats, the story pretty much ends there, but not for unsaturated fats. The double bonds in these molecules have kind of a weird property. They're rigid. So that means that there are 2 ways to arrange every double bond. The first is like this, where both hydrogens are on the same side and both carbons are on the same side. The second way is like this. Now the hydrogens and carbons are on opposite sides of the double bond. Now, even though both of these molecules are made up of exactly the same building blocks, they are 2 completely different substances and they behave completely differently inside of us. The configuration on the left is called cis, which you've probably never heard of. The one on the right is called trans, and you probably have heard of trans fats before. They don't go rancid, they're more stable during deep frying, and they can change the texture of foods in ways that other fats just can't. They're also terrible for your health, by far worse than saturated fat, even though technically they're a type of unsaturated fat. Now, I know that seems crazy, but your body doesn't care what a molecule looks like on paper. All that matters is the 3D shape, where the molecule fits, where it doesn't, and what pathways it interferes with. So how do you know if a food has trans fat in it? Well, the only sure way to know is if you see the words partially hydrogenated in the ingredients list. Don't let nutrition labels or advertising fool you. The FDA allows manufacturers to claim that their products contain, quote, 0 grams of trans fat, even if they actually have up to half a gram per serving. But there are no hard and fast rules about how small a serving can be, and that means you'll have to rely on seeing those key words, partially hydrogenated, because that's how trans fats are made, by partially hydrogenating unsaturated fats. So let's go back to our olive oil and pancake mix from before. Olive oil is 100% fat. Pancake mix is only 11% fat. But olive oil is mostly unsaturated fat, and it has no trans fat at all. On the other hand, more than half the fat in pancake mix is either saturated or trans fat. And so even though olive oil has 10 times as much fat as pancake mix, it's healthy for you, whereas pancake mix is not. Now, I'm not trying to pick on pancake mix. There are lots of foods with this type of fat profile. The point is this. It's not how much fat you eat, it's what kind of fat. And what makes a particular fat healthy or unhealthy is its shape.
Okay, so just a little bit on fat and what that all means. Here we are. And, okay, let's get rid of that. Go back to our screen here. There we go. Okay, so they talked a lot about olive oil being healthy. Now remember, it's a healthy choice for fat. It's not that we want to go and have a cup of olive oil on a daily basis. You would get sick and you would gain a lot of weight, right? But when we're looking at what we want to choose for that fat, every day we should have about 2 to 3 tablespoons of fat. What do we want to use for that, right? Olive oil, better than looking for things like hydrogenated fats. Okay, and I'll talk about that in a second here. Okay, so function of fat in our body. So again, whoops, sorry about that. Again, these underlined words, those are what you're going to write in your booklet, okay? So what does fat do for us? Fat is a fuel, so carbohydrates are a fuel, fat is a fuel. protein really isn't a fuel. Our body uses it as a last resort, but it's not really a fuel that's used much for our body, where carbs and fat are used as fuel. Fat is a major storage site for energy, and humans have an unlimited capacity to store fat. What does that mean? So remember how I said glycogen stores, there's only so much glycogen we can store, and if we exercise more, we can increase how much glycogen we can store? Fat, there's no limit. We can store more fat, and then on top of that, more fat and more fat and more fat, and we can keep storing fat, okay? So there's no limit. So if you eat unhealthily or eat more than what your body needs, you will just gain more and more fat on your body. Okay, so carbs and fats are needed as energy sources. We use our fats with moderate intensity and long duration. So when we're going for a long duration activity, so like a 20-minute jog, because during that 20-minute jog, we're going to use up all of our excess carbs that might be floating around in our body. We're going to use up all the glycogen stores, and our body's going to start using fat. So when we are going for something that's a longer range or longer duration, we need fat to carry our fat-soluble vitamins. A, D, E, and K are our fat-soluble vitamins. So in order for our body to use those vitamins, we need fat for them to be stored in. And then we've also talked about this already. We need fat to support mostly our nervous system, right? And also our internal organs. Now fat, 1 gram of fat has 9 calories. And if you recall, 1 gram of carbs has only 4 calories. So there's a lot more calories in fat. So we don't need very much fat every day. Okay, there we go. So healthy fats. Healthy fats, so these are the ones that are unsaturated. So remember, they're the ones that have that double bond. So they talked in the video here about plant oils. So canola oil, olive oil, flaxseed oil, which is, peanut oil, safflower oil, salad dressings, which are made with plant oils typically, non-hydrogenated margarines, okay? So non-hydrogenated means it's not made with trans fats, okay? So when we buy margarine in our house, I always read the label to make sure it says non-hydrogenated. Nuts and seeds. So when we're thinking about what should we have for our fat in our diet, you can think about these types of things. So maybe add some sunflower seeds to your salad. That will help with your fat, getting that resource in. Now, other fats that are healthy for us, omega-3 fats come from fatty fish. So salmon is a fatty fish. We can also get lots of calcium from eating the canned salmon that still has the bones with it, okay? Eggs have unsaturated fat. So here's some choices that we can have to meet with that 2 to 3 tablespoons a day. Less healthy fats are the saturated fats. These tend to come more from animal fats, okay? So what happens is a saturated fat can actually start our body producing the bad cholesterol. So remember, bad cholesterol builds up on our artery walls, starts plugging our arteries, so less and less blood can get through. So the organs that need that blood supply can be deficient in the oxygen and nutrients and can start to die. Our heart starts to die, we can have a heart attack, okay? So we want to limit our consumption of saturated fats. So in meats, butter, which is an animal product, cheese, this is probably our biggest downfall in my household is we all really like cheese. Cheese is full of saturated fats. And lard, okay? So lard is a animal fat that's a solid fat. Palm and coconut oil have saturated fats in them. We often get saturated fats in our baked goods and processed foods, okay? Butter is often used in baked goods. Butter makes things taste good, so more consumers would want to buy that product, okay? Now, super unhealthy fat is our trans fats, okay? The trans fats, what trans fats do is they can clog our arteries. They can also have an impact on the membrane of our cells and cause damage to our cell membranes. When we read the label, if we read partially hydrogenated vegetable oil, something like that, that's on the list of ingredients rather, not on the label, but list of ingredients, that tells us that there's trans fats, okay? So hydrogenated margarine. So what happens often with trans fats is they want to take what would normally be an oil at room temperature and they convert it to something that would be solid at room temperature so it's easier to package and work with. Okay, that's what that process of hydrogenation does. So you'll see that often in baked goods like this, right? So they have trans fats. What you have to remember is what the video said. If it says 0.5, and I'm not sure what the Canadian rules are, but for the FDA, if you have 0.5 or less per serving, they can say it's 0 in every serving on the nutritional label. Well, maybe the serving is super, super small. But if it's 0.5 for that really small serving and you have 10 of those super small servings, you've now had 5 grams of trans fats, right? So we really want to be cognizant. So you have to read the ingredients, okay? So there lots of processed foods have partially hydrogenated oils, so you have to really read those carefully. Okay, so recommended fat intake about 2 to 3 tablespoons. You want to conserve that to be your healthy fats, but remember, you don't want to eat that on top of. Sometimes it's in our food. So if you have, let's say, a drumstick, well, a drumstick already, like a chicken drumstick, already has fats in it, okay? So then maybe you don't need to compensate by having as much salad dressing, right? We want to make sure that's our total daily intake of fat. And if we decide that we're going to go to McDonald's and have a Big Mac and a large fry and a shake, well, you might have tripled or more the amount of fat you've taken in that day just from that meal. So how can we limit our intake? Choose extra lean meats. Okay, so rather than maybe having a greasy hamburger for lunch, maybe have a piece of chicken. Okay, so watch your intake that way. Cut off visible fat. So rather than eating the fat, so if you have a steak but it's got a piece of fat on it, cut that piece of fat off. Remove the skin from poultry or don't eat it. So if you're having KFC, not the best choice of meals, but if you're having that, pull off the skin and don't eat the skin. Choose cheeses that are lower in fat. Read your labels carefully, okay? So it's really important because it might not seem like it's a product that should have lots of fat in it, but products are good at hiding what they have in it. So you want to read your labels carefully to be able to make the best choices, okay? All right, proteins. So this is our last big nutrient. We'll just cover a couple slides of this because we're getting close to the end of class time here. So proteins, this, like I said, this is a canned PowerPoint that I've added slides to. This one here came out of the can. I didn't really want to change it. I can't make this link work. This one you can watch on your own if you want to. It's about 20 minutes long, I believe. Okay, so where do we get proteins, or where are proteins found in our body? Again, remember these underlined words are words that are in your booklet. Proteins are found everywhere: muscle, bone, tendon, ligament, blood cells, etc. But what we want to remember is our body stores proteins in our muscle. It's found as to build other things, so it helps us to build bone. So we have protein as a structural element of our bone. We have protein as a structural element in our tendons and ligaments. In our blood cells, well, all our cells have protein as part of the cell membrane, as some of the channels that allow for things to move through the cell membrane, for facilitated diffusion you guys learned about, or active transport. On our blood cells, we have a protein called hemoglobin. So hemoglobin is what transports oxygen, or hangs on to oxygen so it can be transported to our cells in our body, okay? Proteins are also part of our enzymes. Enzymes are used for every time we want to have a chemical reaction in our body. Enzymes are used to cause that chemical reaction to happen. That's a protein. Proteins are hormones. So a lot of the hormones that travel through our body are proteins, which regulate different things that are going on in our body. The building blocks of proteins are called amino acids. So we looked at how starches were basically pieces of single sugars. Proteins are made up of pieces of amino acids all strung together, okay? There are 20 different amino acids. So proteins are different combinations of those 20 different amino acids, okay? Primary role of protein: maintain and repair all the body's cells and tissues. A gram of protein is 4 calories, just like carbohydrates. The most protein we'll get in our milk and milk alternatives or meat and meat alternatives. Okay. How much protein we need depends on how old we are and what our level of activity is. So protein needs are higher for adolescents. So people your age need more protein. You're doing a lot more growing than someone my age. Athletes who are restricting calories would want to have more protein. Athletes who are endurance and strength training are going to want to have more protein. That'll help with rebuilding or increasing the size of the muscle. Okay. How much protein we need, this is just a little calculation you can do to figure out how much protein you need to match with your level of activity. Okay, and we are going to stop there. Okay, so a couple of things. We want to just remember that our lecture, instead of Friday, it's going to be on Thursday. By 5 o'clock today, I will have a worksheet ready for you guys. It'll be due Wednesday. And don't forget, you have the musculoskeletal unit test that is already posted. It's been posted since Friday, so get that done before tomorrow. All right, so you guys have a wonderful rest of the day, and I will send you that assignment by 5 o'clock today. Have a great day. We'll see you guys on Wednesday. Okay, and I've got a chat here. Hold on a second. So Braden was asking a question about whether we will learn about other body systems in Meds 20 and 30. Yes, you do learn. I'm not sure which ones are on the list. I think the urinary system was one of them. I can't remember what the other ones are, but you do learn about other body systems, although some of the focus in Meds 20 and 30 is on more hospital care as well. So you'll do some of that and learn a little bit about that. And yeah, so good question. Any other questions? All right, guys, have yourselves a great day. Block yourselves from the wind if you're going outside, and we will see you all on Wednesday.